Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about our GATE courses, you can contact us on these details. Also, you can download Exergic GATE preparation app from Google Play Store. The link is available in the description of video. Now let us carry forward the discussion on 3 to 1 principle. Why are we starting from 3 points? Let us discuss about that. As I told you, in 3 to 1 principle, these are the 3 mutually perpendicular planes, right? And 3 represents that first plane will be restricted, will be supported on 3 points. So why are we starting with 3 points first? Why are we defining the first plane with 3 points? If you have a single point, how many planes can pass from that point? This is a single point. Consider this tip of my finger to be a point. And in the ongoing discussion, I will be telling you the concepts using these fingers or thumb. So whenever I use thumb or fingers, just imagine the single point on the tip of those that is defining this plane. Okay. So if I have a single point, this tip, how many planes can pass from this point? Infinite planes can pass from this point. If I have 2 points, how many planes can pass from this point? Again, a lot of planes can pass from this point. Only a single line can pass from 2 points. If you have 2 points, only a single line can pass from them. But plane, a number of planes can pass. These are the 2 points. You see, all these planes are going to pass from these 2 points. So when you want to define a plane, 1 or 2 points are not sufficient, mainly when you are trying to define the first plane. You need at least 3 points in order to define a plane. These 2 points means the plane can lie anywhere else. But when I add the third point also, then there is only one plane through which these 3 points can pass, or a single plane which can pass from these 3 points, right? If I define this third point somewhere else, then it will be somewhere else. If I define this third point here, then it will be like this. If I define this third point there, it will be like this. And if I define it like this, in the same plane in a way, then this is how this plane is going to be defined. This is the significance of 3. But why not 4? Why not 5? Look, firstly, if we have defined the plane already, there is no need to provide extra points just to locate the point or plane. Logical enough, if something you can do by 3 points, why to add more points? Why to add more supports? More supports you add, more pins you add, right? Support is given by pins, as I showed you. So every extra pin needs extra arrangement. Obviously, it occupies space, it is of some cost. So we will not try to use unnecessarily extra pins. But conceptually, if I tell you, it is very interesting. Conceptually, if you try to add the 4th point or the 4th pin, you may not be able to define the plane. Let me tell you how. Firstly, recall the concept of metrology. Every pin that is made, that pin is not accurately made. There are tolerances given. All the pins are not of the same desired dimension. They have certain tolerance here and there, right? So when I put first point and I put the second point, I want the second point to be exactly along this surface. But there are chances that second point will not be exactly along this surface. I want to align the 2 pins to support a vertical plane. This is the workpiece. I am putting pins to support it. There is no guarantee that the second pin will exactly be touching it or supporting it accurately, because second pin will be having some dimensional tolerance. Even this surface will not be perfectly straight. There will be certain waviness in the surface of this vertical plane. So there will be slight misalignment, although that misalignment will be very small. You don't have to worry about it. That will affect the accuracy of machining. No, machining itself has some tolerances. Machining itself is not accurate. Tool is there, tool is mounted, tool has tolerances. Everywhere there are tolerances. You cannot eliminate it, but you can minimize it, right? So the second pin that you add, that also will be having small tolerance, which is allowed. That okay, this plane perfectly we cannot define, there will be slight misalignment, very slight, when you try to define it using the 2 points. When you add one more point, because third point is needed to define the plane, but when you add one more point, again there is no surety that this third point is going to pass exactly from the vertical plane. This is the workpiece. Inside the jig, you have to support it. Then the tool will come and drill it. So you need to support it at different points. The third point that you put, there is no guarantee that it will be on the vertical plane, just like this workpiece. So what to do? You cannot do anything. There will be some tolerances, but that variation will be very small, so you don't have to bother about it. Even in place of vertical plane, it is slightly by 0.01 degrees, does not matter. Everywhere we are giving tolerance. In the machining itself, if you will create a drill, you will give some tolerance. On the manufactured piece, you will write the drill dimensions, that this much plus minus this much tolerance. You can notice it. Such tolerances are mentioned. But when you add fourth point, then it will be nearly impossible to keep all the 4 points in contact to the workpiece. You can very well understand. If you are able to imagine, just pause the video, close your eyes and imagine what I am telling you. I am further explaining it. If you are not able to imagine, don't worry. But if you are able to imagine, you will enjoy this concept. 3 points are there. Even if the 3 points are not in the vertical plane, still all of them will be in touch with this, because the workpiece can align according to it. There is a slight alignment required. If these are the 3 points, 1 point here, other here, third here, assume, although this much variation will not be there, but assume 1 point is here, other point is here, third point is here, this much variation is present, then plane you have to pass from these 3 points. This is how the plane will become. I know it's not the ideal case. It should be like this. Vertically, this plane should be vertical and this should go in this direction. But even if when 3 points are misaligned, you can touch all the 3 points, because 3 points can perfectly define any plane. Getting? But when you add the fourth point has no guarantee that it will pass from this plane. Even if this plane is right or incorrect, even if this vertical plane you have defined exactly using the 3 pins, or even if there is some misalignment, because these 3 points cannot be perfectly vertical. In vertical plane there will be slight misalignment, but even if there is slight misalignment, or even if they are perfect, fourth point will never lie into that plane. Because when you are defining 3 points, in a way you are defining the plane as well. Whether these 3 points are in the vertical plane or they are slightly misaligned, it does not matter, because you can adjust the workpiece, the plane, such that workpiece contacts those 3 support. Right? Those 3 points, I have told you, no matter what is their orientation, however you put 3 points in your hand, you can always pass a plane from those 3 points, in no matter what alignment you pass them. But if I give you 4 fingers and I ask you that align them in whatever shape, can I pass them a plane through all of them? These are the 3 points. This is the fourth one. Try to pass it from here. If you will try to pass it from here, this will leave. Are you able to imagine? If you try to pass it from here, this one will leave. There is no guarantee that if I have given you 4 points, you can pass a plane from that. No guarantee. If the fourth point is not lying in the plane defined by first 3 points, then all of them will not be in touch. Let me repeat it. If the fourth point is not in the exact same plane, defined by first 3 points, then all of them will not be in contact. And if fourth point is not there, then obviously all of them are not touching it. If you try to touch fourth one, any other will leave the surface. Hence, it is not possible to have all the 4 points exactly in any plane, manufacturing wise. Theoretically, you can have, but manufacturing wise, there will be some tolerances that you can never ensure that the fourth point will exactly lie on this plane, which is defined by first 3 points. It is impossible. What will happen as a result of that? There will be certain wobble. I'm sure you have experienced this. When you have a table, any table you have, generally how many legs it has? 1, 2, 3, 4. In maximum cases, wherever you are, you will see that you can wobble the table. It is not very much sturdy. In maximum cases, there is a slight wobble. You can shake it. What is the reason for that? The same is the reason for that. If you have a perfectly flat plane, perfectly flat, even then, there will be wobble in the table. Even if this table is manufactured by world's best manufacturer, even then there will be wobble in the table. Although that wobble can be very small, you might not be able to even notice it. But there will always be a wobble if a table is placed on a perfectly flat surface. There can be some cases where the surface is not flat, surface is tilted. These 3 points, suppose these are the 4 points, 3 points are here, fourth point is not touching it, but the surface here is slightly curved, then fourth one will be able to touch it, right? So if the surface is not flat, then I am not talking about all these things. We are talking about assuming the flat surfaces. So if you have a perfectly flat surface, it is always sitting, totally sitting on 3 points. Fourth one may be in touch with it, maybe in touch, maybe slightly in touch, but not completely resting or supporting. It is a table, even if it has 4 legs, it is always resting on 3 legs. The fourth one is not perfectly touching it, perfectly pushing against the surface, against the flat surface. It may be partially pushing it, it may be in just contact, or there can be a significant gap which you can feel. But equal distribution, equal push is never applied by all the 4 legs. Effectively, if you talk that how many legs are effectively or completely pushing against the floor, only 3 legs are doing it. That is why if you have a stool with 3 legs on a surface, on a plane, on a flat surface, they will never wobble. Because if they wobble, you are going to fall. Because out of 3, if it is not resting on the third, it is only resting on 2. Then you can imagine that you are sitting on a stool on 2 legs, it is going to fall on either side. That never happens. Again, I am saying, I am telling all these things for a flat surface. Maybe where you are testing it on a floor that is not perfectly flat, and there are planes which are not perfectly flat. In that case, I am not talking. In that case, things can change if the surface has some waviness. But for a flat surface, if you have a 3-leg stool, it will be very sturdy, and in general you will realize it. Any general flat surface you see that is around us, in your office, in your home, generally it is, okay, not perfectly flat, but okayish in terms of flatness. There you can realize, you take a stool with 3 legs, if the surface is okay, not perfectly flat, not very poor, moderately flat, there you will realize that it is not wobbling. But the table with 4 legs, it is going to wobble. The same funda we use in the support of jig. Now recall, when I was teaching you about jig, I told you that there is a concept that I will tell later on. The jig is not directly placed on the work table. because there can be some not only variations in height but also some chips may be lying, machining chips, that can misalign the flatness, the orientation of the jig. So jig is always supported on 3 legs, the whole complete jig setup. If it is not fixed, if you are supporting it using legs, you provide 3 legs for the same reason that if 4 legs are there, there will be wobble. 3 legs will ensure that it is sturdy, it is not wobbling, it is stable. This is the beauty of 3 leg in any discussion that we do in manufacturing. This is a limited application. In manufacturing, at a number of places, this thing is realized. 3 supports. You will realize that they are extensively used to ensure that any tolerance variation that we discussed in metrology is not going to affect our manufacturing process. Now, while providing different supports using pins, there are certain tips, certain rules that you should follow. First one is that whatever is the first surface that you are defining, as I have already told you, these 3 things tell you 3 different planes, surfaces mutually perpendicular to each other on the workpiece. So the point you are using to define that surface, to support that surface, the very first plane where 3 supports are used, second plane 2 supports are used, third plane 1 supports are used. All these 3 planes are mutually perpendicular to each other. So on the very first plane where you provide 3 support, that is called as primary plane. And primary plane generally should be the largest surface area plane of that workpiece. Consider this to be a cuboidal workpiece. This is one area, largest. This is second largest. This is third largest, right? 3 different areas are making up this cuboid. If you want to support this in any jig using 3-to-1 principle, if you want to locate this workpiece, the primary plane will be this one, the largest one. On this plane, you will use 3 pins, then 2, then 1. Okay. Right now, I am not talking about 2 and 1. I am just talking about 3 point, the significance of 3 point, and some of the basic tips and knowledge regarding locating a workpiece. I will discuss about 2 point, 1 point, whole degree of freedom thing we are going to discuss. So don't worry about it. So whenever you are trying to define the first plane where 3 pins will be there, that plane should be largest in area. Rule number 1. These things may be asked to you as a theoretical question. Rule number 2. They should be as far as possible on the given plane. For example, and why should we do it? Suppose this is the primary plane, we want to support it. These are the 3 points where we are supporting it. Okay. If I support it on these 3 points and keep them close, there are chances that it can turn around. But if these 3 points are far from each other, the turning of these is not going to be easy. It's fixing sturdy. Moment cannot be effectively applied about any of the points because they are very far from each other. So their distance from the edge has decreased. So you cannot turn it about the edge. Getting? Second tip, that they should be as far as possible. And third, practical tip. There are certain shapes because workpiece is not going to be of this simple shape. Workpiece can be complex in shape. It can be high in large in dimension, more in weight. I have already told you that if weight is more, you may have to provide additional pins. Then what to do? 3 pins you can support without any wobbling. If you add 1 more, wobble will start. What to do? The 4th pin will be adjustable. Although this much discussion is not required, but the pins internally have a spring setup to ensure that it can be moved up or down. That you can do to eliminate the wobble. 3 points are already there. 3 points. This is the 4th one. Right now it is here, not able to touch it. But if it is adjustable, if you can adjust it, using any of the setup. The spring supported, spring loaded pins is an example of adjustable pin. Then you can ensure that okay, fourth one is also touching it. So in that case, if you have adjustable support, same is true for your table also. In your table also, if you have 4-leg table, fourth one is not contacting or not totally contacting the floor, what do? You make it adjustable. How? You put some paper beneath it. You have 4 legs of the table, fourth one is not reaching up to the surface, not properly contacting the ground. You put some wood below that. You put some cardboard, some folded paper below that. We do it, right? What are we doing? In a way, we are extending its length, adjusting its length to ensure all of them are supporting, are totally supporting the weight of the table. So this is also a similar setup, not similar, conceptually similar. We are adjusting the length to ensure that all of them are contacting the flat surface. Alright, these 3 things I told you. Largest surface should be supported by 3 pins. 3 pins should be as far as possible, and if you add additional pin, it should be adjustable. Alright, these are the basic concepts of pin supports here. Now let us talk about the degree of freedom, and this is something that has more chances of being asked in GATE. And degree of freedom is not something that you are studying for the first time here. We have covered this in theory of machines. That is why there is a logical order in which subjects are to be covered. I see that some of the students start with manufacturing. I don't understand that why they do it. It is not a good way to start. I know that the subject's weightage is high, but weightage does not decide the order in which you have to cover it. To understand completely manufacturing, you need to have the knowledge of strength of material, because we talk about buckling, we talk about bending. You should have the knowledge of heat transfer. We talk about the grain formation. You should have the knowledge of fluid mechanics. We apply Bernoulli's equation in casting. Fluidity of the material comes into the action, viscosity comes into the action while explaining manufacturing. Even you should know theory of machines. Degree of freedom we are talking about when we are discussing manufacturing and production. So all these subjects should be covered before starting manufacturing. Obviously material science and metrology are to be covered, but all these additional subjects other than metrology and material science, you need to cover them before you start manufacturing and production. That is why the degree of freedom that I am going to discuss right now, I am not going to explain again it from scratch. And generally, whenever you cover manufacturing and production, nowhere, no standard books, nowhere they are going to cover degree of freedom from the scratch, because it is a concept of theory of machines. They will tell you some work around, some shortcut way to explain degree of freedom. But if you want to have a total feeling of degree of freedom, you need to cover it in theory of machines. That is what we are going to discuss now, degree of freedom. There is a slight difference between degree of freedom of theory of machines and degree of freedom of manufacturing. I will discuss that in the next lesson. Let us start that.